reflections. So most of us are quite familiar with reflections. We might have done the old butterfly print as a painting exercise when we were a young child, where we painted one side, folded the paper open and opened it out. So we know what reflections should look like. Okay, so the important thing about reflections is you need to know where that center line is, which is often called a mirror line. And when you do your reflections, if they don't actually touch that line, if the picture on this side is a little way away from your mirror line, then you need to make sure that it's the same distance away on the other side. Now, I'm not going to go into this in any detail, but you do need to be somewhat familiar with the equations of straight lines, which are generally given in the format y equals mx plus c. The main thing to remember as well is that if you've got y equals a number, that means that you're going to get a horizontal line on your graph. And if you have x equals to a number, then that's actually going to give you a vertical mirror line on your graph. So let's have a go at a couple. So here we go. So here's our mirror line coming down here through the middle. And the shape we've got here is a little bit of a quadrilateral type shape. I'll just make it a bit darker so you can see it there. Okay, so we literally got to flip it over the line, but make sure it's the same distance away from the line. So this point here is 1 square away from the line, so it needs to be 1 square over there. And then it's 1, 2, 3, 4 lines long, so we're going to draw it 4 lines long here. When you're doing it, please do use a ruler, but in the interest of time, I'm not necessarily going to here. So this point here is 2 squares away from the line, so it needs to be 2 squares away here. It's only 1 square wide, so it stays 1 square wide here. And then the rest of it's quite straightforward to do. Now I will get the ruler out, and we're just going to join up the ends like so. And so we can see our reflected shape there. Okay, here we've got another example. So the mirror line this time, actually you might be able to see that quite well, but I'll still go over that, is here. And this time we have a parallelogram. Also a quadrilateral, obviously, but a special one. So notice that this is 1 square high away from this line. So that line there needs to be 1 square away from the line on the other side. So we'll draw that in. Like so. Then if we pick this point here is 3 away. So it needs to be 3 away on the other side. So 1, 2, 3. So it's going to be there. And it's 1, 2, 3, 4, 5 along. So we'll draw it 5 along. 2, 3, 4, 5. And then all we've got to do is join those ends up. Okay, so these were a couple of fairly simple examples because the mirror line was already given to us and put on the diagram. So we're going to have a look at one where that's not the case. Well, actually, I tell a lie, it sort of is. Okay. So here we have a more graph looking thing. Hopefully you can see this triangle quite well, so I'm not going to go over it. And it tells us to reflect A in the x-axis. So that's this line here. I'm not going to go over it this time. I think that's quite dark enough. So again, remember, this point needs to be the same distance away from the line as it is now. So at the moment, it's 1 away. So we put a blob there, and it's 1, 2, 3 high. So we go up 3. Okay. Now this point here is 1, 2, 3, 4 away, so it's going to be 1, 2, 3, 4 away here. Okay, so just use the ruler to do that diagonal one. So there's our reflected triangle. So we really are going to look at a slightly more complex one now in this next one. Hopefully you can see this nicely because they've made it nice and green up there. Now what it says is reflect the triangle in the line y equals -1. So remember that's going to be a horizontal line. Here's where y equals -1. In fact, y equals -1 everywhere along this line. So it's worth drawing that line in first of all before you start. Then it's just about making sure you're the same distance away. So it's 1, 2, 3 squares away, 1, 2, 3 squares away, and then this is 2 squares high. So I'm going to go to here, okay, and then this point is also 3 squares away, so that's going to go there. So that gives us our straight line, and then over here we put in our diagonal like so. Okay, so to finish off we're going to look at some where the reflections already happened and we've got to describe the transformation that's happened. So it says here, describe fully the single transformation that maps triangle A onto triangle B. So we can see that it's a reflection here. Hopefully you can tell that. So the first part of our description is to say that it is a reflection. The second thing we need to say is what the line is, the mirror line is that it's reflected about. So remember that they have to be the equal distance away from each other. So if we count here, we've got 1, 2, 3, 4, 5 squares between that. So that means, and if you draw it on, it will just help you, that we need to be 2.5 across here. So our mirror line, sorry, it's going to be a bit of a challenge to get it in the middle, is this one here. So remember I told you that if it's a vertical line, it means we've got x equals to a number. So what does x equal here? Well, this is 1, so that's a half. So it's a reflection in the line x equals a half. Okay, so that is the full description of that transformation. Let's look at another one. So same idea here, we've got to describe it. So again, it is a reflection, but we've got a more complex line to deal with here. So let's draw it in first of all. So if we go from here heading towards here, we go across diagonally 1, 2 squares. So that means that here is where the middle or the mirror line is. So let me draw it in so you can see it. So this is our line. So this is a sloping line. So we need an equation for this line that's going to look more like this. So y equals mx plus c. So the c part is 0 because it crosses here, so we can forget that. So we just need to know the gradient of this line. So we do our little triangle thing. And in this case, it's 1 here and 1 here, and 1 divided by 1 is 1. So literally, this is a reflection in the line y equals x, because it's got a gradient of 1 and it goes through the 0. So that's reflections.